Hi, my name is Ingrid Damen. I work for Dyneema and I'm here to show you why Dyneema is the world's strongest fiber, along with some other of its unique properties. I brought you one example of why Dyneema is the world's strongest fiber. I brought you two ropes, a steel rope and a Dyneema rope. Both ropes can carry 40 tons, so that means 2 truckloads each to carry the load. Now if you look at the two ropes, they look the same. The same diameter, they have the same elongation, they work in the same way. However, when you carry them, you can feel the difference. Now if I would just try to catch this steel rope, you can see how heavy it is. If you would do the same thing with the Dyneema rope, just see how easy it goes. And that makes sense, because Dyneema is 10 times stronger than steel or 10 times lighter at same strength. If you would compare Dyneema to polyester, it would be roughly 5 times stronger. And if you would compare Dyneema to a product aramid like Kevlar, would be even 40% stronger. And that is why Dyneema is the world's strongest fiber. In this test, I'll show you the strength of Dyneema by doing a tear test. For this, I brought you two samples. One is a polyester PVC sample that you might recognize from air cargo transportation. I also brought a sample that includes Dyneema. Both of the samples have the same weight. Now let me try to test the tear strength of this sample by pulling it apart. As you can see, I can easily tear this one apart. Now let me try to do the same thing with the Dyneema sample. Oh, I cannot. And that makes sense, because the Dyneema sample is 12 times stronger in tear resistance than this polyester PVC sample. And that's another reason why Dyneema is the world's strongest fiber. Now let me present you another property of Dyneema, which is its unique thermal conductivity. I brought you two samples, a Dyneema glove and an aramid glove. Now the Dyneema glove has a thermal conductivity which is closer to steel, where an aramid glove has a thermal conductivity closer to wool. If we would wear both gloves and touch something that is cool, you will feel that this hand is cooling much faster than this is. And that means that Dyneema transfers the heat of your body faster through the fabric than it is with an aramid. And through that, Dyneema has a cooling effect on you when you're wearing it on your body. To show you the abrasion resistance properties of Dyneema, we've set up a test where we're going to abrade 3 different fibers over this abrasion tool: polyester, aramid, which we know as Kevlar, and Dyneema, and see how long they last when we abrade them over this abrasion tool. Now let me show you how long it takes to abrade polyester over this abrasion device. 1, 2, 3. 3 times. Now let us see how long a much stronger fiber, like aramid or Kevlar, will hold on this abrasion device. 1, 2, 3, 4, 5, 6, 7. 7 times. Now let's see how long we need to break the Dyneema on this abrasion device. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now we can go on forever until we maybe have 100 cycles. But as you can see, the Dyneema will last much longer in abrasion resistance. And when you look at my fingers, they're absolutely punched through because of the force that I put on that device.